Hello, it is lesson 4-1 time, and we are going to be classifying triangles today. We are going to classify triangles by their angle measures and their side lengths, and we're also going to use the triangle classification to find angle measures and side lengths. So as you can see, for all of our vocabulary, we're just going to see our next page here. So let's move on to those vocabulary words. So an acute triangle, first of all, we're going to classify the triangles by their angle measures. Then we're going to classify triangles by their side lengths. So by their angle measures, we have 4 different classifications: acute, equiangular, right, and obtuse. So an acute triangle has 3 acute angles. So all 3 angles are acute. They're all smaller than 90 degrees. So that would be an example perhaps of an acute triangle. All 3 angles are less than 90 degrees. An equiangular triangle has 3 congruent acute angles. Okay, so that is going to look like this. All 3 angles are equal to each other. A right triangle has 1 right angle. And so a right triangle would look like this, where you have one of the angles you are told is a right angle. And an obtuse triangle has 1 obtuse angle. So that might look like this, where you have this angle here is greater than 90 degrees, but of course less than 180. Okay, so now we're going to try to do some triangle classification by side lengths. When we did it by angle measures, we had 4 different classifications. When you go by side lengths, you only have 3: equilateral, isosceles, and scalene. An equilateral triangle has 3 congruent sides. So that's going to look just like the equiangular one from above, except for we say that the sides are equal. An isosceles triangle has at least 2 congruent sides. So that's going to look like this, where you have 2 sides congruent. And you'll notice it says at least. That means that an equilateral triangle is also an isosceles triangle. It's just a special type. The isosceles triangle has at least 2 sides, so it could also be 3 sides, in which case it would also be an equilateral. A scalene triangle has no congruent sides. So a scalene triangle may look like this, where you have all 3 sides of different lengths. So let's do a couple of examples. If we're to classify these triangles here by their angle measures, let's first figure out what the different angle measures are. So this right here, the whole angle is 70 plus 30, so that would be 101. And then the rest of these are already pretty much filled in. So let's see if we can figure out what their angle measure classifications are. So triangle DBC. So triangle DBC is this one on the right hand side. And you can see that it has 1 right angle, so we'll say that that is a right triangle. Triangle ABD, so ABD is here, and that also has 1 right angle. It's not written, but since this is a straight line and half of it is 90, we can assume that the other half is also 90, so that is a right triangle as well. Triangle ADC is the big triangle here, and you'll notice that the big triangle has an angle of 101 degrees, which is obtuse. So that would be obtuse. Okay, now take a look at this other triangle here. We want to find out what the lengths of LH, HS, and LS are. You'll notice that it is equilateral, and we know from up here that equilateral means three congruent sides. If they're congruent, they're also equal to each other. So you need to choose, and in this case we have 3z minus 1, z plus 5, and 4z minus 4. You have actually more information than you need to decide to try and figure out what z is. We need to choose two of these. It doesn't matter which two we choose. I'm going to choose this one here and this one here. So I'm going to go z plus 5 equals 4z minus 4 and solve for z. So subtract z's and add 4. That turns to a 0, this turns to a 0, and I'm left with 9 equals 3z divided by 3, and 3 equals z. So I could have chosen any of those two, and I should have gotten still 3 equals z. So now let's plug it in and see what we get for each of these. So 3 times z is 9. 9 minus 1 is 8. So this is LH is going to be 8. I should get 8 for all the rest of them. Let's just double check and make sure we did it right. Z plus 5 is 3 plus 5, which sure enough gives us 8. And LS is 4z minus 4, so that's 4 times 3 minus 4, which is 12 minus 4, which is 8 again. So we got all three to be equal, which we should have, because these little marks on them told me that all three sides were equal. Okay, so that is classification of triangles using their angle measures and their side lengths.